All right, so we're going to start looking at Chapter 8, which begins with what we call the law of sines. Okay. The next two sections, which we'll spend 3 days on, we'll learn about law of sines and law of cosines. And those two laws are basically used to find out how big the sides are in a triangle and how big the angles are. And if you're thinking, well, we've already done that. We've already figured out sides and angles. Yep, we have. What kind of triangle did we always work with in the past when we were trying to figure out the sides and the angles? Yeah?
Right triangle.
We always worked with the right triangle. So the law of sines and cosines allows us to figure out sides and angles when you don't have a right triangle. Okay. So when you don't have a right triangle, that's called an oblique triangle. And there's really two different types. You could have an oblique triangle where all the angles are smaller than 90. Think of like an equilateral. That's one example. That's called an acute triangle. Or you could have an oblique triangle that's obtuse. An obtuse triangle is where you have one angle bigger than 90. Could you have two angles bigger than 90? No, why not?
Because the angles have to add up to 180.
Right, the angles have to add up to 180. So if you're going to have an angle bigger than 180, it has to just be one angle, not two. If you're dealing with a triangle. A triangle that's on a flat surface. Right, that's everything that we study. We study trig on a flat surface. Okay, there's a whole bunch of other stuff you can do with trig if you study it on a curved surface. Right? Like technically, if you connect like North Pole, Boston, and England, right? That makes a triangle, but it's curved, so it's a whole different type of trig. Okay, so we've got a diagram that we use for solving triangles. How do we normally label the sides? What are the variables we use? Yep.
ABC.
ABC. Yep, we're going to use those same variables again. What do we name the angle that's across from A? Yep.
Alpha.
Alpha. How about the angle across from B? Beta. And the angle across from C was always the right angle, so we didn't have to give it a name. Well, now the angle across from C is not a right angle, so we need to give it a name, and that is the Greek letter gamma. Gamma. Okay. What is similar to what we've done before is you always need to have three pieces of information. Okay. When you solved the right triangle, I always gave you three. You had the right angle, that was always given. And then I either gave you two of the sides, or you had the right angle, and I gave you another angle and a side. What's different, though, is depending on what three pieces of information you have, it's going to control how you solve it. Okay. Certain sets of information are going to be doable with law of sines. Other sets of information, like if I gave you a side, and a side, that's going to be a law of cosines law. And you can't really switch it. If you try to use the wrong formula, it won't work. You won't have enough information to plug in. So the kinds of problems that we're going to look at are these three. The first group is where I give you two angles and a side, but the placement is a little bit different. So with angle, side, angle, I would give you two angles, maybe like this, and the side is between the two angles, like that. That's angle, side, angle. Side angle, angle is the same pieces of information, but they're in different spots. So that would be something like I give you a side, let's say over here is 15, I give you an angle, and I give you another angle right there. That's side, angle, angle. The side that you know is not the one that connects the two angles. If it's the one connecting them, then it's between them. That's the first case. So there's a diagram of each type. Okay, side-side angle. That one's a little bit different. You're being given two sides to start and an angle, but the angle cannot be between the two sides. If the angle was between the two sides, this formula we're learning today doesn't work. That's law of cosines. All right, so let's say this side is 8, this side is 10, and to make it side-side angle, I can either give you this angle or I can give you that angle, just not that one. Okay. That one wouldn't work for today. So let's call that 40. So that's a side-side angle problem. Okay, when you write the abbreviation, it's depending on the kind of triangle we're solving. I'll usually reference these 3 letters. If you write angle, angle, side, that's okay. It's the same thing as side, angle, angle. If you write this one backwards, well, it's the same thing. I prefer you leave this one in that order, though. That's nicer. Any questions on that? Okay. So, any of those 3 types of problems are going to fall under the law of sines, and only those 3 types. The only 2 types I have not talked about, and I will not until a couple lessons from now, are side, 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 SSS, and side, angle, side, SAS. We can't do those 2 with this formula. Okay, so we're going to try to take a look at where the law of sines comes from, and then we'll use it to solve some problems. All right, so let's look at this. All right, what kind of triangles do we know how to work with right now? Yep.
Right triangles.
We know how to work with right triangles. Okay, so what I'm going to do is I'm going to try to make a right triangle by doing that. I actually made 2 right triangles. First question, do the 2 right triangles that I just created look congruent? No, they're not. They're not congruent. They're totally different. Okay, I do need to label some sides. Okay, I'm going to call this side A. I'm going to call this side B. I'm going to have a right angle right here. I'm going to call this H. I'm just calling it H because it's the height of the triangle, not because it's the hypotenuse, so maybe that's not a great choice. But let's call that H. Let's call this angle beta because it's across from B, and alpha because that's across from A. All right. So there's my setup. Okay, what I want to do is look at each triangle separately. Okay, so I'm going to start by just focusing on the triangle that's on the left. Okay. I would like to write a trig function that's going to involve those 3 sides. What position is side H relative to beta? H is it's the opposite. What position is side A? Yep, hypotenuse. So I want to write a trig function, and it needs to involve opposite and hypotenuse. Which trig function has those 2 in it? Yep, sine. So the sine of my angle equals opposite over hypotenuse. Okay, and now what I would like to do is solve that for H. How do I get H by itself in that above equation? Yep.
Multiply both sides by A.
Multiply both sides by A. So there is a formula that calculates the height of the triangle. And I'm going to call that box 1. Any question on that formula? Let's do the same thing again. This time, let's look at that one. Okay, I want to find a formula, again, and it's going to involve this, this, and that. Okay, what position is side H now relative to alpha? Yeah,
The opposite side.
it's opposite. And what position is side B?
Hypotenuse.
It's hypotenuse. So I need a trig function that involves opposite and hypotenuse, which would be, yep, sine again. And can somebody fill in the rest of that equation for me? Sine of what equals what?
Sine.
Yeah,
Sine of alpha equals h over b.
h over b. Okay, I would like to get h by itself again. How would we get h by itself in that equation? Wait, multiply both sides by b. And there is a formula that would also calculate the height of the triangle using different information than we did before. Right. Any question on that formula? Okay. Now, I have a formula in box 1 that equals h, and I have a formula in box 2 that equals h. What does that tell me about box 1 and box 2? Yep.
They're equal.
They're equal, right? They're both equal to h, which means what's in box 1 and what's in box 2 is equal to each other. So let's write that down. Let's put sine of alpha, oops, jumping ahead a little bit, b sine alpha equals a sine beta. We know that's true because they both calculate the height. Now what I'd like to do is put the a over on the side with alpha and put the b over on the side with beta. What could I divide each side by that would move both the a and the b to the other side at the same time? Yeah?
Divided by alpha and beta.
No, alpha and beta are part of an argument to a trig function. You can't touch the alpha and the beta.
Divided by AB.
Yeah, divide by AB. Good. Okay, when you divide each side by AB, that cancels the b's, and we're left with sine of alpha over A equals sine of beta over B. And that's the first two parts of the law of sines. Sine of alpha over A equals sine beta over B. There is a third part to it. Scroll down. There's the first two. We didn't prove the third part, but I'm hoping based on the pattern of the first two, you can predict what that last fraction is. I could prove it. I could just draw the height from a different side. But the way I did it, I got the first two parts. Anybody have a guess what the third part is? Yep.
Sine of gamma divided by c.
Yeah, sine of gamma over c. That is the law of sines. Sine of alpha over A equals sine beta over B, which equals sine gamma over c. When you are using the law of sines, you never have to use all three parts in the same problem at once. You pick two of the fractions and you use them. at a time. Either the first two, the last two, or the first one and the last one. Once you do that, you're going to have four things, because you're going to have a fraction and a fraction. There's going to be four spaces to plug things in. You need to know three of them. Okay? And by you need to know, I mean you need to be given three of them. And then you solve for the fourth one. Remember, all the angles, even though we don't have a right triangle anymore, all the angles still add up to, yep,
180.
yes. All the angles still add up to 180. Okay, so as far as kind of explaining and going through what the formula is, that's it. Now we'll try one example of each type. Okay, what I usually do if I teach law of sines and cosines in the same week, I usually put 6 questions on the test because they can take a little while to do. But each question has 3 things you have to find. Right? So that it really comes out to like 18 different answers that you're trying to do. All right, so don't think that this would be worth just one question when we solve a problem like this. It would be worth 3 questions. Okay, so the first thing we have to do eventually is we're going to have to figure out if this is law of sines or if this should be done with law of cosines. To do that, we've got to figure out, is it one of these 3 types? What's the easiest way to see if that is one of those 3 types?
Draw it out.
Draw it out. Yep. So let's make a sketch. We're going to put A over here, across from alpha. Let's put B across from beta, and C across from gamma. This is not necessarily to scale. Okay, when I draw it, I just make sure A and alpha are opposite, and so are B and beta.
It's SAA.
So this is a side, an angle, and an angle. Yep. And the side is not between the 2 angles. So that is the type I referred to right there. Side angle angle. Is side angle angle one of the 3 that we use law of sines for? Yeah. Yep. So now we know, you don't know law of cosines yet anyway, but now we've confirmed it is law of sines problem. Okay, set up a table. Okay, just like we did before. Okay, we're going to fill in everything we know. So alpha is 20. We know beta is 60. And we know A is 4. Now, when we solved right triangles, I told you you could do anything you want in any order. Okay? Didn't matter what you find first. Here, you have a couple options, but you definitely cannot find C first. That's impossible. You cannot do that. The reason you can't find C is because that row is completely empty. If you have a row that's completely empty, that's not a very useful row to use. Okay? There's nothing in it. We need to figure out something in that row another way first. So is there anything we could figure out in that row first? Yep.
We know that gamma equals 100.
Gamma equals 100, yes. Okay, because alpha, beta, and gamma all have to add up to 180. Yeah. Okay. Now, when we also did this right triangles, what did I say about using the piece of information we just found to figure out other things? Yeah.
That you showed because it could be inaccurate.
Right. It could be inaccurate, even worse, it could be worse than a rounding error. It could be, yeah?
Straight up
It
wrong.
could just be wrong, right? So there's an accuracy issue when you round, but then it could just be wrong. Well, Can't do that this week. In order to find C, you have to use gamma. There is no other way to do it. So that means if you get gamma wrong, you will get C wrong. But you could still get B right, because B doesn't have anything to do with gamma. So what I'm getting at is there is more interdependence on the answers. Okay, so you're going to have to use things you found to find other things. But since now we have a piece of information in every row, we no longer have any rows that are totally empty. We can find B or C next. It doesn't matter. So do we want to do B or C?
B.
B. Yeah.
Oh, I was gonna say the equation.
Oh, which one to do next?
Say, yeah.
Okay. So if we want to find B, we want to look at the table. And the first thing we want to do is find the row that has everything in it. Okay. What row has both pieces of information filled in?
A.
Row A. So that is a very important row. We're going to use this part of the law of sines because we know both pieces of information. And we're going to use this part because we chose to find B. So sine of alpha over A equals sine beta over B. Okay, so let's write that down. Sine, you pretty much start every problem like that. So now it's sine of alpha over A equals sine of beta over B. And that's a very special kind of equation. You have a fraction on one side and a fraction on the other. What do we call this kind of equation? There you go. Into the P. Something. All right. Well, how would you solve that equation then? Yeah? Cross multiply. What kind of equation do you solve with cross multiplication? Proportion? Yeah, proportion, right? Cross multiply. So we're going to cross multiply. That's going to give you B sine 20 equals 4 sine 60. So that's from cross multiplying. And then what's your last step to get B by itself?
Divided by sine 20.
Divide by sine 20. Your answer. Okay, so we'll type that in. We're going to round everything to 3 decimal places. Okay, 4 sine 60 divided by sine 20. Okay, so make sure you're in degrees. You can do problems like this in radians. I don't think any of the ones in our book are in radians. Okay, they're all in degrees. Divided by sine 20. It is important that you close that parenthesis. We don't want to have anything extra in the first argument, just the 60. Okay. That gives me 10.128. Okay, so now I got my first side. Now, can we use Pythagorean theorem to get C?
No,
Why not?
because you can't use one you rounded. You have to use one that they gave you. Okay? Like you can't do anything, or you can't use any information you solve for because it could be wrong, or it could have like a rounding error to it. So it's not-
Okay, so that's generally, yeah, that is true. We're going to have to use the 100 anyway, and we were not given that. So we're going to have to use information that we were not given anyway. But yeah,
It's not a right triangle.
that's not a right triangle. That formula doesn't even apply. Okay? It's like using the wrong key on a door. Right? It's not going to work. So we can't use Pythagorean theorem here. So we have to find C the same way that we found B. Okay, so let's do that. So that was find B. Let's find C. So you always start with sine and sine. And you pick a row that has everything in it. Okay. Now I have two rows that have both pieces of information. Which row should I choose?
Row A,
Yeah, how come?
because that's guaranteed correct.
Yeah, because we at least know everything there is correct and everything is accurate. There's no decimals. So we're going to do sine 20 over 4 equals, and what's going to go on the other side to find C? Yep.
Sine 100 over C.
100 over C. And you kind of want to get used to that cross multiplying. If we can do it in one step, that's going to be good. It's going to be 4 sine 100
Divided by sine 20.
divided by sine 20. There we go. Don't try to do anything fancy and do like, oh, 100 divided by 20 is 5. I'll just do the sine of 5. No, right? You got to type it in just the way you see it. So 4 sine 100 divided by sine 20.
11.57 or 518.
11.51. Yep.
Another reason why you can't use it, because you have to round that to something exact, because you're getting off for the next
Yep.
7 days.
So remember, just like with triangles, keep in mind the biggest side should always be with the biggest angle. Smallest side should be with the smallest angle. And any two sides added together need to be bigger than the third. If any of that doesn't happen, then something is very wrong. Yeah.
Is the calculator in radians or degrees?
We're in degrees,
Okay.
because all my angles were given in degrees.
Okay, that's what I thought.
Yep. Okay. And that's a law of sines problem with angle, angle, side. Side angle. Okay. Any questions on that one? Okay. Let's look at this one. This time you already have a diagram, so we can figure out what type it is pretty quick. Using the 3 letters, what type of triangle is this one? Yeah.
Acute.
Using the 3 letters.
Angle side.
It's angle, side, angle. Is ASA one of the 3 types we are supposed to use law of sines for?
Yeah.
Yeah. Okay, so we're going to make our table. Okay. Do we know A?
No.
No. Do we know B?
No.
No. Do we know C?
Yes.
Okay, what's C?
4.
Because it's across from gamma. Do we know alpha?
Yes, 45.
It's across from A. And do we know beta?
Yes.
How much?
40.
40. As you do lots of law of sines problems, you start to kind of notice a pattern. When you set up that table, it is very important that you have a full row. If you do not have a full row, or you don't have a way to get a full row, you're not going to be able to use law of sines. That's why if I give you side, 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 you do not have a full row. Same with side, angle, side. You would not have a full row, and you would have no way to find a full row without using trig. Okay? So we need to be able to always have a full row to use law of sines. Okay. Do we have a full row with what was given?
No.
No. So then we're either not going to be able to use law of sines, or we're going to have to be able to find a full row without using anything that's like heavy with trig, something more basic geometry. Okay. Anything we can figure out. Yep.
Gamma is 95 because is it 95?
Yes.
Yeah, it's 95
Yeah.
because it all equals up to 180.
Okay, so that has to be 95 because those two add up to 85. And 85 plus 95 gives me 180. Any questions on that? Okay, now we have a full row. This row is going to be used to figure everything out. It's the only full row you have. So that means if we get this wrong, everything's wrong. Okay, so we really got to make sure that we just add those up and subtract from 180 and get that answer exact. All right. Now, it's the same kind of problem as the last one. We can do A or B first. So which one do we want to do first? Yeah. A. Okay, so let's find A. Can somebody give me the equation that I'm going to set up to find A? Yep.
Sine 95 over 4.
Sine 95 over 4. Yep, you just got to do sine of an angle, divide by what's across from it. Doesn't matter which one you do first.
Oh, then 45 over A.
And what's on this side?
45 over A.
Sine 45 divided by A.
Yep.
Okay. When I solve for A, can somebody tell me what A is going to equal when it's all by itself? Yep.
A is going to be 4 sine 45 over sine 95.
Perfect. So 4 sine 45 over sine 95. 4 sine 45 divided by sine 95. Okay, so that's A, 2.839. Okay, and let's look at finding B. So find B. We're going to set it up, start it out the same way. Okay, what could I put on the left?
95 for sine gamma over c.
Okay, yeah, sine gamma over c, sine 95 over 4. Somebody else tell me what's going to go on the right. And remember, we're trying to find B. Wait.
Sine 40 over b.
Over B. Yep. So you're going to cross multiply, and you're going to get 4 sine 40 over sine 95. Okay, let's type that in. Since I'm just changing one number, I can just press second enter, bring up the last thing I typed in,
And just go over to 45 and get 40.
and just make that a 40. Okay, so 2.581. All right, so both cases where I start you off with two angles and a side, they're both pretty similar. Any questions on those two? Okay. So, the last one. Let's draw that out, but you can already tell it's different because all the other two I gave you two angles and a side. I'm not giving you two angles there. So let's draw it and just see what type it is. So we've got A, alpha, B, beta, C, gamma. All right. What type of triangle is that one?
SSA.
That is SSA. Okay. Out of the 5 different types that we were learning, SSA is kind of the one that we generally don't care for as much when it comes up, because what can end up happening here is when we start to solve this problem, it could turn out to be a regular problem. And we just get one solution for each of the three things we don't know. Or we could end up with two solutions for each of the three things we don't know. So that means you'd be finding 6 things. Or we start to solve the problem and we realize the information they gave us would never make a triangle and it's impossible. Right? So we still have 3 things we don't know, but there might be one answer for each of them, 2 answers for each of them, or no answer for each of them. Okay, but they have to go together. They either all have 1, they all have 2, or it's all no solution. Okay. Let's make our table. And inside side angle, you are very restricted. You cannot do what you want first. You always have to find something first. What is it that you are forced to find first here?
B.
What is it?
Beta.
Beta. Why not C or gamma?
Because you don't have enough information for either of those yet.
Yeah, we don't have enough information to do anything with that bottom row, and I have no way to find any information in that bottom row. So I have to find beta first. Okay, the order that we're going to follow as we go through this one, you're going to have to do that first, then you can do that second, and then you can find C third. But as we go through it, at some point we need to figure out, are there 2 answers that we're going to put in this box? 2 answers here and 2 answers here? Is it 1 answer in each box? Or is it no answer? They're all no solution. That's impossible. Okay. So let's set it up and see if we can find beta first. What's going to go on the left side?
Sine alpha over A, which would be sine 40 over 3.
Yep, sine 40 over 3. And what's going to go on the right side?
Sine beta over B or sine beta over 2.
Sine beta over 2. Okay, before we go any further with that, I want to just look at it. And can somebody tell me what is different about that? Yep.
We have to solve for the top for beta instead, so
So what are we solving for then?
the sine.
Well, the sine, that's a function name. But what is it that we're trying to figure out there?
The angle.
The angle, yes. We're trying to find the angle. And anytime that you want to find an angle, what is always going to come up eventually? This is the only way to solve for angles in trig.
Inverse trig.
Inverse trig. You're going to have to use inverse trig. And anytime you use inverse trig, the ASTC chart comes up. Okay? So let's go through and see what happens. Okay. First, I'd just like to get sine beta by itself. So you could cross multiply, but the goal is just to get this alone, which we can do easier than cross multiplying.
Multiply both sides by 2.
Just multiply both sides by 2. So 2 sine 40 divided by 3 equals sine beta. Now I want to get beta alone. What do I have to do on each side?
Take the inverse sine.
Take the inverse side. Okay, we know inverse sine and regular sine cancel each other out. And now, let's type that in on the left and see what we get. Okay, second inverse sine of 2 sine 40 divided by 3. Okay, this is not a no solution problem. If it was no solution, then I would have gotten an error right now. Okay, I would have tried to take the inverse sine of something either bigger than 1 or, well, yeah, it would never be negative because we're dealing with a triangle. But I would have ended up trying to take the inverse sine of a number bigger than 1. Clearly, I didn't do that because I got an answer. So 25.374 is definitely an answer for beta. Okay, so let's write that down. I'm going to put it up a little higher in the box, just in case there's a second answer. All right. Now, you should be able to tell me how to get the second answer. What quadrant would I be looking in for the second answer? Yeah?
Quadrant 2.
Quadrant 2. It'd be impossible to look in quadrants 3 and 4 because those are angles bigger than 180. You can't have angles bigger than 180 in a triangle. So I have an answer in quadrant 1. How do I get the answer in quadrant 2?
180 minus reference angle,
And what's my reference angle?
25.374.
Yep, so 180 minus 25.374. I'm not going to write that in the box yet. I'm going to put that off to the side and put a question mark. If there's a second answer, that's what it would be. 154.626. So that's how you find the possible second answer. Subtract the first one from 180.
Well, that couldn't work
Why can't that work?
because we already know one angle is 40. So 154, without even doing the decimals, plus 40 is 190.
Right. That's too big. Right? You were given a 40. The second possible answer is 154. That is too big to fit. Okay, it's not going to work. If this angle that was given was like a 20, and we got a 154 here, then yeah, that would work because you can add them up and it's not bigger than 180. Because the second answer did not work, there is no second answer for beta, there's no second answer for gamma, there's no second answer for C. You don't have to worry about a second answer for any of them. Now that I know alpha and beta, how can I get gamma? Yep.
You can subtract it to 25.374 and 40 from 180.
So we're going to subtract the sum of those two. That gives me 114.626. And now you do have to use that 114 to find C.
But now it's using the other formula, so that's nice.
So to find C, we can use law of sines.
So we're using A,
We're going to, definitely use the top row because it was given.
sine 40,
It's the same row we used the first time.
give that 3,
Equals?
sine of 114.626 over C.
Yeah. And now we just cross multiply. So C is going to be 3 sine 114.626 divided by sine 40. So it's 4.243. And that's the only type that we're going to focus on for now. Okay, the case where it does only come out to a single answer. The two-answer case, that'll be next time. All right, so the homework is the take-home. I'm going to put a time on it. You'll have, I'll give you 100 minutes. So, nice number, 100 minutes. Okay, so a little bit more time than you'd normally have in class. Okay, it's due at 8. When does our class? No, it's due at 9:15 a.m. Eastern Time on March 7th of this year. If you don't want to take it as a take-home because you're just worried about internet, you don't have time tonight, come talk to me and let me know. Is anybody not doing it as a take-home?
I'm certainly going to try to.
Okay. Test will open at 2:40 today. It'll be open at 2:40. Yes.